Alright, so in the previous video, we took a look at an example where we were analyzing a mixture of aspirin and caffeine. And we said the first thing that we have to do is make standards, one for aspirin and one for caffeine, if that's what we're analyzing. And we have to figure out what concentrations do we need in order to get that accomplished. So we talked about using Beer's law, looking up the molar absorptivity in the book with aspirin, looking up the molar absorptivity in the book for caffeine, and then using Beer's law to figure out how strong I need to make these solutions. Then I made the solutions, I ran them on the UV-Vis, and now we're taking a look at using a corrected molar absorptivity. So what happened is that we talked about aspirin first, and we said we ran aspirin on the UV-Vis, and we looked for the lambda max at 229, and that lambda max gave us a 0.672. We're off from 1. It should have been 1, but we're off from that number, and we talked about why. So we're going to have to use this absorbance and the concentration that I made, and we recalculated a molar absorptivity that we will actually use in the problem. So this is the recalculation of the molar absorptivity. So here 866 is the molar absorptivity that I will use for aspirin. Okay, so now we're going to do the same thing to caffeine. And we're going to look at caffeine standard, and we're going to run the caffeine standard on the UV-Vis. And we're going to get a spectra. And the spectra maybe looks something like this. So I'll look at the spectra, and I take a look at my maximum absorbance, which is going to happen here. And I'll look at the nanometers of that peak, and that nanometer is going to be about 272. Okay, so there's the lambda max for caffeine. And at 272, we don't get 1 perfectly. We get 0.941. And again, we're assuming that we've made our sample correct. We've weighed out the proper amount of caffeine standard. We dissolved it in the volumetric flask. Everything is okay according to the solution prep. And I've double-checked my numbers, and I've double-checked those calculations, and I don't see where I went wrong. I made 1.17 times 10 to the negative fourth exactly. So I need to calculate my real molar absorptivity that I need to begin using in this problem. Okay, so I can use Beer's law all over again, just like I did with aspirin. My absorbance is 0.941. Molar absorptivity, I'm trying to calculate the actual lab molar absorptivity. I'm going to multiply by 1, which is the path length, and then I'm going to multiply by C, which is the concentration that I made. And that concentration is 1.17 times 10 to the negative fourth, right? It was right here. That's what I decided to make to get a 1 absorbance. Well, I didn't get a 1 absorbance, did I? I got something close, but not exact. So now I need to solve for E, and the way that we do it, we take 0.941, and then we divide it by parenthesis 1.17 times 10 to the negative fourth, and that gives me a molar absorptivity value. When I do that calculation, that molar absorptivity is going to come out to be about 8042. So again, this is off from the book value, but this is kind of what all of my calculations are going to be based on. It's that instrument that I'm using, those solvents that I'm using. So I need to keep this consistency throughout the entire lab procedure. So this is the molar absorptivity for caffeine, not the 8510 that I found in the book. We're going to be using 8042. So this is calculating the molar absorptivity for each one of these. Okay, so I use Beer's law in the beginning to give me a target molarity. That's what I call these. So these are target molarities. So target molarity for aspirin and the target molarity for caffeine. I make those samples at that strength. I then turn around and I run them on the UV-Vis. This gives me some data analysis. I get the lambda max for my first component and the absorbance, and I get the lambda max for my second component and the absorbance. I then use that absorbance and my target molarities that I made to calculate the true molar absorptivities that I will begin using for the problem to analyze this mixture. Okay, so that's going to be it for this video. We've kind of went at least partially there. I now then need to start cross-referencing these two components. So what does that mean? Well, that basically means that now I've got aspirin data. I need to get more aspirin data at the caffeine settings. And now that I've got caffeine data, I need to get more caffeine data, but this time at the aspirin settings. So we're cross-referencing the two components, and that's how we do it. All right, so in the next video, we'll pick up from there. We'll take a look at cross-referencing the two data pieces, and we'll clean up this math sheet a little bit and start basically fresh on a new sheet of paper. So stay tuned for video 3. This is going to be one of those multi-component example problem video questions again, just because there's so much that's going on. So stay tuned.